Okay, so I'm going to take a look at practice problem 2 on page 238. So we have a swimming pool with given dimensions, and we have a truck with capacity that's defined, 5,500 gallons, and we want to know how many trips the water truck has to make to fill the pool. Okay. Also, we're looking to find the mass and the weight of the water in the pool. All right. Okay, so if just kind of just thinking about the approach is that you're given the density, and if you're given the density, of course, density times volume will give us the mass in the pool, and of course, weight is very easy because it's just going to be mass times the gravitational acceleration. Okay, then we have to think about depending upon the truck's capacity. We can very easily come up with a volume here, and this is a volume. Of course, the units aren't the same. And you think about, well, whatever the truck's capacity, whatever the pool's capacity is, or how much we're putting in the pool, divided by the capacity of the truck, of course, would give us the number of trips that would take us. Okay? So just kind of a general thought of how we're going to go approach it before I actually get into the details of solving it. Okay. So we're looking for N, number of trips, the mass of the water in the pool, and the weight of the water in the pool. All right. So we're given some quantities. We're given the volume of the pool, and I just went through and did the calculation here. We're also given the volume of the truck, and what I recognize is that our density was given in terms of slugs per feet cubed. So from that perspective, I need to make a conversion. And also, when we go to figure the number of trips, we also need to have these two in the same units, right? So the units I chose to go to, which was more convenient, was to go to feet cubed. Okay, so I just took the volume feet cubed, volume of gallons, and I used the conversion factor of 1 cubic foot of volume is equal to 7.48 gallons. Okay. So I just converted that, and you come up with the volume of the truck is 735 feet cubed. Okay. Then this was another given quantity. So these are really the given quantities, right? 735 feet cubed. Then we had the density of water, which is 1.93 slugs per feet cubed. Okay, so that was also given. All right. So governing equations, mass, of course, is equal to the density times the volume. The weight is equal to mass times gravitational acceleration. And we just have to make sure we're in the right units. And the number of trips basically is just the volume of the pool divided by the volume of the truck, right? Volume. So this is like volume per truck load, okay? So this will give us the number of trips. All right. So just going through, and I originally wrote this down wrong. So mass of water is equal to density of water times the volume, which was just 1.93 slug per feet cubed times the volume gives us 8340 slug. Okay, that's a little bit different than the mass that they had listed in the solution. Maybe they used a slightly different number for this one. Maybe they extended it out a little further. This is just 3 significant digits for that, for the density of water. Okay, to come up with it slightly larger than this. All right, so then I go and do the weight of the water is just going to be the mass of the water times gravitational acceleration, and the units I'm using, of course, are USCS units. Okay, and that comes out to be 2.69 times 10 to the 5th pounds force, or 269,000 pounds. Okay, then the number of trips. It's just going to be the volume of the pool divided by the volume of the truck per trip, which comes out to be 5.89. All right. Well, you can't have a partial trip, so you got to put this essentially to the ceiling or the next integer above this or next whole number above this. And this comes out to be n equals 6, okay, since you can't have a partial trip. And that's pretty much it for that particular problem.